Hello everyone. I will now work on the questions under the free response section of project 2. Now at this point I would like to remind you that it is very important that you clearly show all steps in the solution process to receive full credit for your work, because every step has points assigned to it based on the grading rubric, and if you miss a step you will lose the points for that step. Question number 1 says, in the graph of the trigonometric function of the form y equals a times sine of bx minus c plus d, identify what each of the letters a, b, c and d represent and how they are used to graph the function. In other words, they are asking us to describe what the role of each of these letters a, b, c and d are in the graphing process. As the first step, I will write out this entire general form of the variation of a function. So y equals a times sine of, now they're talking about the sine function here, but it could be cos, it could be tan, or any other function, within brackets bx, and then we have a minus. It's very important to get the signs correct as well. It's minus c, the operators, minus c, and then outside the bracket we have plus d. We will start with the letter A. A stands for the amplitude of the graph, or the amplitude of the function. The amplitude refers to the vertical stretching, or it could even be shrinking. So it refers to the vertical stretching or shrinking of the graph above or below the x-axis, and it is denoted by the formula absolute value of a. Now, if a is a value greater than 1, then the graph gets stretched. Its peak points, in other words, rise up or falls below the x-axis. If it's a fractional value between 0 and 1, then there's a vertical shrinking of the graph. Instead of extending up to -1 and +1 for the sine function or the cosine function, it will extend to whatever the absolute value of a is. If a is 2, then the graph will get stretched to +2 and it will go down to -2 below the x-axis. If the absolute value of a is, let's say, 1/2, then the graph will shrink down to half above the x-axis and -half below the x-axis. So that's what the purpose of the amplitude is. The formula is simple. It's just the absolute value of a, and it determines the vertical stretching or shrinking of the graph. Now let's look at the letter B. What the letter B determines is the period of the graph. For now, let's talk about the period. B is also used for another purpose, to determine the phase shift of the graph. Therefore, B is used for two purposes. We'll come to the next one later on, but for now, let's look at the period. A variation of a function can have a different period than the basic function, right? Now, for the basic sine function, the period is normally 2 pi. The new period will be determined by whatever value B has. The formula for that is take the normal period of the function and divide it by whatever value B has. That will give you the period. That means the interval within which the graph will complete one full cycle is the period. So depending on the value of B, the period of the graph can change, and the formula to calculate the new period would be 2 pi divided by b. That's one of the functions of b. What about the other function when we find the phase shift of the graph? Let's come to that when we talk about the letter C, the function of the letter C. C is used to determine the phase shift of the graph. What do we understand by the phase shift of a function? It tells us about the horizontal shifting of the graph along the x-axis, horizontal shifting. That means how far along the x-axis would the graph shift, either towards the left or towards the right. In other words, it tells us about the horizontal displacement of the graph. The graph slides either to the left or to the right based on the phase shift of the graph. How do we calculate the phase shift? Using the formula C divided by B. Now, if C divided by B is positive, then the graph slides so many units, C over B units, to the right. If it is negative, then the graph shifts C over B units to the left. So the horizontal shifting is also determined by the sign that C over B takes. All right. So let me write that. So if C divided by B, if that value is a positive value, then the graph slides C over B units to the right. If C over B is negative, then the graph slides C over B units to the left. All right. So as I told you before, B is used not only in the calculation of the period, but also in the phase shift. For the phase shift, we also look at the value of C. So C is used to determine the phase shift along with B. The next is D. The letter over here outside the brackets is D, and it's a plus D in the general form, in the original form. What does D determine? It determines the vertical shifting. So while C determines the phase shift of the horizontal shifting of the graph, D determines just by itself the vertical shifting of the graph. And there's no formula, it just depends on the value of D. So what does vertical shifting mean? It means the entire graph is going to either move up or move down depending on the value of D and the sign it has. So the graph slides vertically up or down. So again, D determines the vertical shifting of the graph. The entire graph can go up or it can slide down. If D is positive, then the graph will slide up. If D is negative, then the graph will slide down. And it's the entire graph. And you have to know the difference between vertical stretching, shrinking versus vertical shifting. Vertical shifting slides the entire graph up and down the x-axis, whereas in the case of the stretching and shrinking, the graph is anchored in its original place. However, the points get stretched by quantity which is determined by A. All right? Hello everyone. We will now work on question number 2 under the free form section of project 2. This is a question on graphing of trigonometric functions. However, this is not a multiple choice question. Here we will have to work through the steps one at a time and then sketch the graph of the function. The function given to us is y equals 3 times sine of 2x minus pi. We have to first determine the amplitude, period, phase shift, if any vertical shifts are applicable, and then graph one period of the function. The first step is to write out the general form of the function with all its variations included, and that would be y equals a times sine of bx minus c plus d. And then we will take the function given to us, which is again y equals 3 times sine of 2x minus pi, and align it with the general form so that we can easily identify the values of a, b, c, and t. So that's what I'm going to do here. Y equals 3 times sine of 2x minus pi, and then since there's nothing outside of the brackets, I'm going to just write plus 0. Now let's try to align the variables with their respective values. A will have a value of 3, a equals 3, b is equal to 2, c is equal to positive pi. whatever remains after you pull out the negative sign, because when you align the equation, it has to match exactly, even with the signs, the variables, everything. All right, so here we have a 2x minus pi. So whatever comes after the minus sign would be the value of c. In this case, it is pi. And then d has a value of 0, and we've kind of forced that to match the form because there's nothing after the brackets in the function given to us. Next, we will work on finding the amplitude of the function. The amplitude is determined by the value of a. It's the absolute value of a. Here, a has a value of 3, therefore the absolute value of 3 is 3, and that is the amplitude of the function. What is the amplitude? It tells us the vertical stretching or shrinking of the graph. That means, based on this amplitude, the graph will have its peak point at y equals 3 and its lowest point at y equals negative 3. The graph will be stretched vertically. Next is to identify the period. Now we know that the sine graph has a period of 2 pi. However, this function with all the variations will have a different period. How do we find the period? You take the period of the basic sine function, which is 2 pi, and divide it by b. 2 pi divided by b will give us the period of the function. So 2 pi divided by b has a value of 2. Therefore, 2 pi divided by 2 gives us pi, and that is the period of this function, which means that the function will complete one full cycle within an interval of pi units, whereas the basic sine function has its period at 2 pi. It completes one full cycle in an interval of 2 pi. For this particular function with all its variations, the period will be pi units. Next is the phase shift. The phase shift is about the horizontal shifting of the graph. The graph will slide either to the right or to the left along the x-axis. That's what the phase shift is about. How do we calculate the phase shift? It goes by the formula c divided by b. Now, let's find out the value of c here. It's a positive pi, and b has a value of 2. Therefore, pi over 2 is the phase shift of the graph. But how does it translate to a horizontal shifting? Since pi over 2 is a positive value, the graph will shift pi over 2 units to the right. That's what this value tells us. If the phase shift has a positive value, the graph shifts horizontally to the right. If it is a negative value, it will shift horizontally to the left. Now we have a positive value, so we are going to say that the graph will shift pi over 2 units to the right horizontally. Now let's think about vertical shifting. Would there be any vertical shifting involved here? Let's try to determine if there'll be any vertical shifting of the graph. That means whether the graph could move up or down along the y-axis. That's what the vertical shift is about. The vertical shift is determined by the value of d. Now here we have d equals 0. So vertical shift is determined by the value of d. D has a value of 0, therefore there's no vertical shift. Let's write that. There's no vertical shift in this function. Now we have come to the step where we'll need to find the values of x for the 5 key points. Now it's important to find those 5 key points of x first, because later on we will find their corresponding y values. They will give us a set of ordered pairs which we will plot on the graph, connect them, and get a complete graph of the function, right? We begin by finding the distance that will be placed between each of those 5 key points. The distance is calculated by taking the period of the function, which in this case is pi, correct? The period of this function that we are working with is pi. It's not 2 pi, so it's pi divided by 4. It's divided by 4 always for any function, all right? So pi over 4 is the distance that we are going to place between each of these points. We will start by finding x sub 1. Now, if there is no phase shift in your function, then make x sub 1 equal to 0. However, if there is a phase shift, then make x sub 1 equal to whatever the value of the phase shift is. In our case, for this function, we have a phase shift of pi over 2. Therefore, I'm going to make x sub 1 equal to pi over 2. That's what we are going to start with. For x sub 2, all you're going to do is add x sub 4, this distance, the value of the distance, to pi over 2. So it'll be pi over 2 plus pi over 4, which is equal to 3 pi over 4. For x sub 3, take the 3 pi over 4, which is the value of x sub 2, and add pi over 4 to it. So it'll be 3 pi over 4 plus pi over 4, which is 4 pi over 4, which is equal to pi. Next is x sub 4. To find x sub 4, take the pi from the previous point and then add pi over 4 to it. You will end up with 5 pi over 4. And finally, for x sub 5, the fifth key point, take 5 pi over 4 for the previous point, add pi over 4 to it. You will end up with 6 pi over 4, which is the same as 3 pi over 2, correct? So now we have the 5 key points. Let's write it down here. It's pi over 2, that's the first one, followed by 3 pi over 4, followed by pi for the third key point. Then we have 5 pi over 4, and then finally 3 pi over 2, which is the same as 6 pi over 4. So 3 pi over 2. What will be the maximum point of this graph? The maximum point will be determined by the value of a. So a was 3, therefore the highest point of the graph will be at y equals 3, and the lowest point will be at y equals negative 3. And this is because we do not have a vertical shifting in the graph. You can just write the value of a above the x-axis. If it's below the x-axis, the minimum point will be below the x-axis, so it's going to be a negative value. All right. Now, if there was a vertical shift, you would have to add the value of the vertical shift to each of these numbers in order to come up with the maximum and the minimum point. Right. Next step is to find the values of y for the 5 key points that we came up with previously. So let's do that. X equals pi over 2 was the first key point. What will be the corresponding value of y? Here we have to evaluate our trigonometric function by plugging in the value of x. So what was our function? It was 3 times sine of 2x. So x has a value of pi over 2. So I'm going to substitute x with pi over 2 minus pi. That was the function that we were given. Now 2 and 2 divide, and we are left with 3 times sine of pi minus pi is 0. So 3 times sine of 0. Sine of 0 is 0, correct? So we end up with 3 times 0, which is equal to 0. Therefore, y has a value of 0 when x equals pi over 2. The next one is, let's look up the next key point for x. It was 3 pi over 4. Let's write that here for x. 3 pi over 4. It's the same function, just plug in 3 pi over 4 for x. So 3 times sine of 2 times 3 pi over 4 minus pi. So 2 and 4 will divide. We'll be left with 3 times sine of 3 pi over 2 minus pi. Let me write that down as a separate step. 3 pi over 2 minus pi equals 3 times sine. Always show all your steps. It'll help you to get your answer correct as well as get partial credit. So 3 times sine of 3 pi over 2 minus pi is pi over 2. And sine of pi over 2 has a value of 1 from our special angles table. So that'll be equal to 3. So when x is 3 pi over 4, y has a value of positive 3. Now the next key point for x was pi. So let's write pi here and evaluate the function same way by plugging in pi for x this time. So it's 2 pi minus pi, which is 3 times sine of 2 pi minus pi is 1 pi. Sine of pi equals 0. So 3 times 0 will give us 0 again. So when x is pi, y is 0. What was the fourth key point? It was 5 pi over 4. Therefore, 5 pi over 4. Let's do the evaluation. 3 times sine of 2 times 5 pi over 4 minus pi, which gives us 3 times sine of 3 pi over 2. Correct? Now, sine of 3 pi over 2 is negative 1. You have to know the ratios from the special angles table. You have to have it memorized, please. Otherwise, you will get all the answers wrong here. You're not allowed to use calculators on your tests. Therefore, make sure that you know your special angles table well enough. So 3 times negative 1 is negative 3. So when x is 5 pi over 4, y is negative 3. Finally, the last key point was 3 pi over 2. Let's do the evaluation again. 3 times sine of 2 times 3 pi over 2 minus pi. 2 and 2 divide. We have 3 times sine of 3 pi minus pi is 2 pi, and sine of 2 pi is 0. So we end up with 3 times 0, which is 0. So now we have 5 ordered pairs. We are going to go to our graph and plot them. All right. Now here is our graphing area. What I've done here is I have changed the intervals. Since the period is pi units for this function, it would be a very cramped graph. Therefore, I've changed the interval values here from what was given to us only for the positive x-axis. Well, I can change it here as well. Make it negative pi over 4, then negative pi over 2, negative 3 pi over 4. This is negative pi and so on. All right. So I did that purposely so that we can have a nice, well spread out graph. What we do here is we plot our 5 ordered pairs that we just found in the previous step. When x equals pi over 2, y equal to 0. So let's find our pi over 2 along the x-axis. Y is 0 at that point. So I'm going to mark here as a point which is 0, correct? At x equals pi over 2, y equal to 0. Let's look at the second ordered pair. When x is 3 pi over 4, y equals 3. So where is 3 pi over 4? It's right here. Y equals 3. Let's mark that with a dot. Next we have pi. At x equal to pi, y equal to 0. So which would be this point here. And then at 5 pi over 4, y equals negative 3. This is 5 pi over 4 on the x-axis. Negative 3 is right here along the y-axis. So this is where our plot is going to be. And finally, at 3 pi over 2, y equal to 0. Here's 3 pi over 2. We are going to have a dot here. So we've plotted all these points. All we need to do is connect these points. So let's do that. And that's our graph for the function given. That would be 3 times sine of pi. All right. So this is the process of graphing step by step the graph of the sine and the cosine trigonometric function. For the tangent function, some of the steps are a little bit different. So we'll work on a separate problem for that. But for the sine function, this is how you would go along graphing the function. All right? We will now work on question number 3, which is also on graphing, but this time it's the graph of a cosine function. The function given to us is y equals 2 times cos of half x, and then outside the brackets we have a plus 1. We will work it out the same way as we did for question number 2 on graphing the sine function. It's the same process, but we will end up with the graph of the cosine function instead of the sine function. So the question reads, determine the amplitude, period, and phase shift of each function. It says phase shift, but we also have to find out if there's any vertical shifting or not. Then graph one period of the function. We will start with writing out the general form of the function with all its variations in it. So let's write that. Y equals a times, this time it's the cosine function that we are working with. So I'll write a times cos of bx minus c, close the bracket, and then plus d. That's the general form. Now we'll take our given equation and align it with the general form. That would be y equals 2 times cos of 1/2 x. Now there's nothing after half x, therefore I'm going to write it as minus 0, and then outside the brackets we have plus 1. Now let's try to identify the values of a, b, c, and d. A has a value of 2, so a equals 2, which will become the amplitude of the function. B has a value of 1/2, C has a value of 0, and D has a value of 1. D equals 1. All right. So now that we have identified the values of A, B, C, and D, let's go on to finding the different variations of the graph. The amplitude is determined by the value of A, which is 2 in this case. Therefore, the amplitude will be the absolute value of A, which is the absolute value of 2, therefore 2. That means the graph will be stretched up to positive 2 above the x-axis and negative 2 below the x-axis. However, we also have to account for the vertical shifting. So I'll talk about that later on when we get to drawing the graph, or even when finding out the maximum and the minimum points of the graph. All right. But for now, let's know that the amplitude will be 2 units. That's the vertical stretching of the graph. Next is identifying the period. We do that by taking the period of the basic cosine function, which is 2 pi, and divide that by b. So 2 pi divided by b has a value of 1/2. 2 pi divided by 1/2 gives us 4 pi, and that is going to be the period of the graph of this function. That means one cycle of this function will be within an interval of 4 pi units, not 2 pi, but 4 pi units. Next is the phase shift. Again, phase shift is about the horizontal shifting of the graph. It could shift either to the right or to the left horizontally along the x-axis. To find the value of the phase shift, you take your c divided by b. C has a value of 0, b has a value of 1/2. 0 divided by anything is 0. So 0 divided by half is 0, which tells us there's no horizontal shifting involved in this function. Therefore, we can write it as no phase shift or no horizontal shifting in this graph. There's no horizontal shifting in this graph. What about the vertical shifting? Vertical shifting is determined by the value of D. Now here D has a value of positive 1. So D equals 1, and it's a positive 1. That tells us that yes, there is a vertical shifting of the function. It'll go up 1 unit along the y-axis. Therefore, the vertical shifting will be 1 unit up. If D is a positive value, then the graph shifts up. If D is a negative value, the graph slides down along the y-axis. All right. Next step is to find the values of the 5 key points for x. We'll start by finding the distance between each of those 5 key points, the distance that we will place between the 5 key points. How do we find that? Take the period that we found for this function. In our case, it's 4 pi. So let me write that here. Distance between each of those key points would be measured or found by dividing the period, which is 4 pi, by 4, correct? So 4 pi divided by 4 gives us pi units. That means the distance between each of these points will be pi units. That's the interval between the points, all right? Now, it says find the values of x for the 5 key points. Let's start by finding the value of the first key point, x sub 1. What did I say before? If there's no phase shift, then make x sub 1 equal to 0. However, if there is a phase shift in the function, which you will know by now, we did that before we came to this step, then use the value of the phase shift as the value of the first x key point. All right. So in this case, phase shift is 0. So x sub 1 equal to 0. All right. In other words, we are just using whatever the value of the phase shift is as the first key point for x. All right. Now for x sub 2, you have to add pi to the previous point that you found. So x sub 1 was the previous key point. So it will be 0 plus pi would be the value of x sub 2. X sub 3 would be found by taking the value of x sub 2, which is pi, add pi to it, which gives us 2 pi. Then x sub 4 would be 2 pi plus pi equals 3 pi. And finally, x sub 5 would be 3 pi. So we are basically taking the value of the previous key point for x and adding the value of the distance we found at the beginning. So 3 pi plus pi equals 4 pi. So let me list the values of the 5 key points that we just found. For x, it would be 0, and then pi, 2 pi, 3 pi, and 4 pi. So we got our 5 key points. The next question is find the maximum point. That means where would the peak point of the graph be and where would the minimum point of the graph be. Now, if there is no vertical shifting in the graph, then it is just the value of A. If there is a vertical shifting of the graph, then you will have to add the value of the vertical shift, the value of D, in other words. We have a vertical shift here of 1 unit. Therefore, take the value of the amplitude, which is 2, and the value of D is 1. So 2 plus 1 will give us 3. That would be the maximum point. So this would be at y equals 2 plus 1 equals 3. And the minimum point would be at y equals negative 2 plus 1. That would be at negative 1. So essentially the formula is to take the value of A. For the maximum point, take the value of A and add D to it. For the minimum point, take the value of negative A and add D to it. All right, so that's essentially the formula to find the maximum and minimum point if there is vertical shifting involved. The next question is to find the corresponding y values for the 5 key points. All right, so let's do that. The first x value that we found was 0. So let's write 0 for x, but we have to find the y value that corresponds to it based on the function. So what was our function? It was y equals 2 times cos of half. Now I'm going to plug in the value of 0 into x. So it'll be half times 0 and then plus 1, which will give us 2 times cos. Now half times 0 is 0. So cos of 0 and then plus 1. Now cos of 0 is equal to 1, correct? So 1 times 2. This is what we are going to get. 2 times 1 plus 1 which is equal to 3. That means when x equal to 0, y will have a value of 3. So again, you first calculate the value of cos of 0, which is 1. You have to know the special angles tables very well. All right. So cos of 0 is 1. You multiply the 1 by the 2 and then add 1 to it, which gives us a 3. The next x value was a pi. That means into the function, I will substitute pi for x. So half times pi plus 1. We get 2 times cos of pi over 2 plus 1, which gives us cos of pi over 2 is equal to 0. Cos of pi over 2 is equal to 0. So 2 times 0 plus 1 equals 0 plus 1 is a 1. So y equals 1. What's the third x key point? It's 2 pi, correct? So 2 pi, again, same process. This is very mechanical. So 2 times cos of half times 2 pi plus 1 outside the bracket. So 2 and 2 divide. We get 2 times cos of pi plus 1, which is cos of pi has a value of -1. So 2 times -1 plus 1 equals -2 plus 1 is -1. So y equals -1 when x equals 2 pi. The fourth value for x was 3 pi, correct? It was 3 pi. So let's do the evaluation again. 2 times cos of half times, now x is 3 pi. So 3 pi plus 1. We have 2 times cos of 3 pi over 2 plus 1, which is cos of 3 pi over 2 is 0. So 2 times 0 plus 1 gives us 1. So when x is 3 pi, y equals 1. Finally, when x is 4 pi, let's finish the last evaluation. Half times 4 pi plus 1. 4 and 2 divide. We get 2 times cos of 2 pi plus 1. Cos of 2 pi has a value of +1 plus 1 gives us 2 times 1 is 2 plus 1 is a 3. So y equals 3. Now we have our set of ordered pairs that we are going to plot on the graphing paper and connect the points to get our graph. So let's go on to the graphing area. The first ordered pair is 0, 3. So let's go down to our graph. 0 is here. This is 0, 3. The next point would be pi, 1. So pi, 1 is right here. That's our second point. The third point is 2 pi, -1. 2 pi is here. 2 pi, -1 right here. And then we had 3 pi, 1. 3 pi is here and 1. All right. So 3 pi, 1 is this fourth point. And finally, we have at 4 pi, y equals 3. So at 4 pi, y equals 3 would be this point here. All right. And now all we have to do is connect the points. And this is our graph. So this green curve is the graph of y equals 2 times cos of 1/2 x plus 1. All right. Hello, everyone. We will now work on question number 4 in project 2, which is on graphing of the tangent function. The function given to us is y equals 2 times tan of 2x. Now, if you recall, the process of graphing a tangent function is slightly different from graphing a sine function or a cosine function. The steps are a little bit different. A tangent function would have asymptotes in its graph, so we will have to locate the position of the asymptotes. That's one of the steps in graphing a tangent function. However, we will begin the same way as we did with the sine function or the cosine function, in the sense that we will start by writing out the general form of a trigonometric function. The general form of the trigonometric function is a times tan of bx minus c plus d. Now we will align the given function with the general form so that we can identify the values of a, b, c, and d. We will write it as y equals 2 times tan of, within brackets, 2x. Now there's nothing after the 2x, so I'm going to write this as minus 0 plus 0 outside the brackets, because there's no brackets involved and therefore nothing outside the brackets either. Now let's identify the values of a, b, c, and d. A has a value of 2, b has a value of positive 2 as well, c has a value of 0, and d has a value of 0. Let's write out these values. A equals 2, b equals 2, c equal to 0, and d equal to 0 as well. Next is to find the amplitude. Now, for the tangent function, the amplitude or the value of a is used differently from the way we used it for the sine or the cosine function. But let's just identify the value of the amplitude, because we will use it later on for one of the steps where we find the coordinates at 1/4 distance and 3/4 distance between the two asymptotes. All right. So the amplitude is the value of a. Let's write that. Amplitude is the absolute value of a. A has a value of 2, therefore absolute value of 2. Therefore, it is 2. Next is to identify the location of the asymptotes. Now, the location of the asymptotes could be found using this formula, minus pi over 2 less than bx minus c. Therefore, bx minus c less than pi over 2. Now, where did I get the values of negative pi over 2 and positive pi over 2? If you recall, one period of the tangent function occurs between negative pi over 2 and positive pi over 2. That for the basic tangent function. The tangent function has a period of pi units, and one of the periods occur between negative pi over 2 and positive pi over 2 in the basic tangent function. Therefore, if we can solve this equation for x, then we can find the location of the left-hand side asymptote and the right-hand side asymptote. So this is how I'm going to go ahead and solve this. Now there's no minus c in our equation, therefore we can forget about the minus c, correct? We can cross that out. But bx has a value of 2x. Therefore the way we will solve this is make bx equal to negative pi over 2. Now b has a value of 2, so 2x equals negative pi over 2. Therefore, solve for x, all right? So in that equation, solve for x. If we solve for x, that means divide both sides by 2, we will end up with negative pi over 2 multiplied by 1/2, which is negative pi over 4. So one of the asymptotes, the left-hand side asymptote, will occur at negative pi over 4, left asymptote. For the right-hand side asymptote, do the same thing, but this time we will use pi over 2. First, let me start by writing bx equals pi over 2, and bx is 2x, which is equal to pi over 2. Solve for x. X would be equal to pi over 2 multiplied by 1/2, which gives us positive pi over 4. And that's where the right-hand side asymptote would be located at. All right. So we have found the position of the two asymptotes. Again, the way of doing that is equate bx to negative pi over 2 for the left-hand side asymptote, solve for x, and you will get the left-hand side asymptote. For the right-hand side asymptote, make bx minus c equal to pi over 2 and solve for x. In this case, we came up with pi over 4. Now, why did we cross out negative c? Because c has a value of 0. We really don't have anything after 2x. That's why we wrote it as bx equal to pi over 2 and bx equals negative pi over 2. Next is to find the midpoint. The midpoint will always be the point which is located midway between the two asymptotes, negative pi over 4 and positive pi over 4. The center point would be at x equal to 0. So midpoint would be at x equal to 0. The midpoint is always the center point between the two asymptotes. Therefore, x equal to 0 is where the midpoint of the graph will be. The next step is to find the points x comma y which are located at 1/4 and 3/4 way between the two asymptotes. Now, we have to find both the x and the y coordinates. The value of the y coordinate 1/4 way will be negative a. And remember, at the start I said that the amplitude will be used differently for graphing the tangent function. Now we will be using the value of the amplitude. We'll start by finding x comma y 1/4 way between the two asymptotes. That's what we are working on first. Y will be equal to negative a. In this case, we have a as 2, so it's going to be negative 2, right? We already know the value of the y coordinate 1/4 way, so I'm going to write it as x comma negative 2 to start with. And now I will find the value of x, given that y is negative 2. Now, in order to do that, we are going to use the function given to us, which was y equals 2 times tan of 2x. That's the function given to us. We just found that y equals negative 2. So let's plug in negative 2 for y, and we have to solve for x. So negative 2 equals 2 times tan of 2x. Divide both sides by 2. We end up with negative 1 equals tan of 2x. So now we will have to solve for x. Now, to solve for x in this equation, we have to ask ourselves, for what angle measure is the tangent ratio equal to negative 1? Use your knowledge of the special angles table. You will remember that tan of negative pi over 4 equals 2x, correct? Negative 1 equals tan of negative pi over 4 from our special angles table. Therefore, we can equate negative pi over 4 and 2x. So we can write an equation which is 2x equals negative pi over 4 and solve for x, correct? So x would be equal to negative pi over 4 multiplied by 1/2, which is negative pi over 8. All right, now that we know the value of x, I'm going to write negative pi over 8 as the x coordinate 1/4 way between the two asymptotes. This is negative pi over 8. So 1/4 way between the asymptotes, we have a point that would be negative pi over 8 comma negative pi over 2. Now we have to find the x and y coordinates 3/4 way between the two asymptotes. Again, same process, but 3/4 way between the asymptotes, y would be a positive a. It's going to be a positive a. 1/4 way it was negative a. 3/4 way it's positive a, therefore y equal to 2. Let's write it as an ordered pair. Y will have a value of positive 2. X is what we need to find. All right, but the process is the same. We have to solve the equation by plugging in 2 for the value of y. It will be 2 equals 2 times tan of 2x. Divide both sides by 2. We end up with 1 on the left-hand side. And then on the right-hand side, we have tan of 2x. Use your knowledge of the special angles. For what angle measure is the tangent ratio equal to 1? It's pi over 4, positive pi over 4. So 1 equals tan of positive pi over 4. We will now equate 2x with pi over 4 and solve for x. When we are solving for x at this stage, we can forget about the tangent. We are just equating the 2x with pi over 4. So 2x equals pi over 4. Therefore, x will be equal to pi over 4 times 1/2, which gives us x equals pi over 8. Now we can proceed to draw the graph. We have all the information that we need in order to draw the tangent graph. The information that we will be using is the asymptotes, where they are located, minus pi over 4 and positive pi over 4, the location of the asymptotes, and then the center of the asymptote, which is x equal to 0. Also, the ordered pairs, the x and y coordinates, 1/4 way and 3/4 way. So let's go down to the graphing area. Here we are, the graphing area. The graph is scaled along the x-axis by pi over 2 intervals. However, I'm going to change this a little because we should get a spread out graph really. Otherwise, it'll be too cramped if I don't change the intervals. I'll make this pi over 4 units. So this minus pi over 2, I will be changing that to minus pi over 4. And on the right hand side, positive pi over 2, let's write that as pi over 4. All right, and we can just keep going, minus pi over 2, positive pi over 2 on the other side, and so on. All right, but we have been asked to draw the graph within one period. So as long as we stay between negative pi over 4 and positive pi over 4, that's good enough. We'll start by drawing the asymptotes first. So let's go back a little bit to make sure we got the asymptotes right. It's at negative pi over 4 and positive pi over 4. Let's mark the location of the asymptotes. One of the asymptotes is going to pass through negative pi over 4 on the left hand side, and on the right hand side the other asymptote will pass through positive pi over 4. So here I have it as a vertical dashed line passing through positive pi over 4 on the right hand side and negative pi over 4 on the left hand side. Now the midpoint between the two asymptotes would be the center point, which is 0. This is the midpoint of the graph. Next is to plot the points 1/4 way. At 1/4 way between the asymptotes, it's negative pi over 8 comma negative 2. Where will negative pi over 8 be? Negative pi over 8 is going to be midway between negative pi over 4 and the center point, correct? So let's mark it here between negative pi over 4 and 0, right? This point is 0. And then for the 3/4 way, it's going to be right here between 0 and right hand side asymptote. Let's mark this negative pi over 8 and positive pi over 8. What were the corresponding y values? Negative 2 and positive 2, correct? So negative pi over 8 comma negative 2, let's mark it here. And positive pi over 8 and positive 2 will be right here. All right. So the next step is to just connect the points that we found and extend the graph all the way up along the right hand side asymptote and all the way down along the left hand side asymptote. So let's do that. It will go like this. All right. So this is the graph of our tangent function. Let me just use a different color also to explicitly show our tangent function that we just graphed. All right.